So very good morning, all of you. Okay, so it is in the last class I have explained about the filters. Okay, so it is what is that filter? It is used to remove the unwanted part of the signal here. Okay, and according to this one in the power supply, so it is filters are used to remove the AC component. Okay, it will allow to pass only the DC, and it is to be classified into the main two types. It is one is of the C filter, one more is of the pi filter. Okay, if you take the C filter, so that arrangement of the capacitor is to be in parallel, it is with the load there. If you take the pi filter, so that arrangement of the capacitor, it is to be what so that you are so that you are using the two capacitor, it is parallel to it is each other, and in between, so that you are using one inductor, and it is going to take the shape of the Greek letter, it is pi, so it is called as of the pi filter. Okay, and in this class we are going to study about the voltage regulator. It is concerned to the unit 1 of the analog electronic circuits. It is for the diploma ENC. Okay, so in this voltage regulator, okay, so that you are going to study the definition of the voltage regulator, is what is the need for the voltage regulator in the power supply, and the voltage regulator circuit using the zener diode, it is line and the load regulation, and an op amp series of voltage regulator using the zener diode. Okay, all that we'll see in this class. Okay, and here in this case, if you take the definition of the voltage regulator, if you take the definition of the voltage regulator, a voltage regulator is an electronic device. It is designed to maintain the output voltage of the power supply is nearly constant with irrespective of the changes in the load, supply voltage or the temperature itself is called as an voltage regulator. Okay, suppose consider that you can see this block is acting as an voltage regulator. So the input is an unregulated voltage here. So it is having the variations here. So it is whatever the DC voltage is there, it is having some amount of the ripples here, or it is some amount of the variations. Okay, it is going to vary according to the variations of the load, or according to the variations of the supply voltage, or according to the variations of the temperature. It is going to vary in this case, and in order to maintain so it has the constant as in this way, a single straight line. Okay, so that you can observe here, in order to obtain the output as of the single straight line, so that you are using the voltage regulator. So for that purpose, the input voltage for the voltage regulator is an unregulated voltage. This is the output of the filter. Okay, in order to implement the RPS, so that you are using the transformer, it is to be followed by the rectifier, it is to be followed by the filter. What that output of the filter is there, no, it is acting as an unregulated voltage, and it is itself is inputted to as an input for the voltage regulator, and the output of the voltage regulator is constant. It is with the irrespective variations of the load or the input voltage or the temperature. Okay, it is itself is called as an voltage regulator. Okay, in brief, so what actually the voltage regulator it will do is, it is going to give you the constant voltage, constant DC voltage. Okay, so so again I am going to repeat. An voltage regulator is one of the electronic circuit. It is used to maintain the voltage of the power supply as the constant. It is with the irrespective changes. Either any of the load resistance is going to change, or the applied input is going to change, or whatever the surrounding temperature is, it is going to change. Its output is going to be the constant. So it is itself is called as an voltage regulator. Understood? Okay. And it is what is the need of the voltage regulators in the power supply. So the voltage regulator is necessary because an unregulated supply is not good enough. So that if you are using the very minute or it is very delicate equipments in the what any of the circuit building and of the ICs or etc, it is to be get operated with the exact DC voltages. In order to maintain the exact DC, the constant voltage, so what this regulator is to be needed, because the unregulated power supply is not good enough, because in the unregulated power supply it is having the poor regulation. It is due to the voltage drop in the internal resistance. So if any of the component internal resistance is going to vary, according to that the unregulated output is also going to vary there. So it is having the poor regulations. It's where in the unregulated power supply, and the variations in the AC main supply. If the AC main input, if it is going to vary, if it increases the voltage according to that, it is what that unregulated output increases. If the AC main supply decreases, so that unregulated supply is also going to decrease there. So according to the variations of the AC main supply, so that unregulated supply is going to vary. And another parameter, so another reason is the variations in the temperature. So what this temperature is also going to play the vital role here. So according to the variations of the temperature, okay, it is also going to vary that unregulated output voltage there. So so all these variations, it may vary the DC output voltage, and it may cause an inaccurate or the erratic operation. In order to overcome the above, in order to overcome the above means what, in order to overcome the poor regulations, in order to overcome the variations in the AC means, and in order to overcome the variations in the temperature, the voltage regulator is to be needed. So if you are using the voltage regulator means, either if it is having the poor regulations also, it can be overcome. And if it is if any of the alterations in the AC main supply also, it can be taken care by the voltage regulator. And if the variations in the temperature occurs also, it is also going to be taken care by the voltage regulators, and it is going to give you the constant output voltage. Understood? It is what is the need for the voltage regulator. So the voltage regulator is to be needed. It is because in unregulated power supply is not good enough. In the unregulated power supply, it is having the poor regulations. It is having the variations in the AC mains, and it is having the variations in the temperature. So in order to overcome all the three, so the voltage regulator is in needed. It's required here. Okay, understood? So it is the need of the what voltage regulators in the power supply here. Okay, and after that, if you see, it is one circuit diagram of the voltage regulator using the zener diode. So in the zener diode means, it is going to be implemented as in this way. Yeah. So if you take the zener diode here, okay, a zener diode is always operated in its reverse bias condition. So that you can able to see the circuit diagram, the arrangement of the zener diode is under the reverse bias. What this upper part is the anode, what this other end is the cathode, indicated with the negative mark, and what this anode is indicated with the positive. And this arrangement of the diode is to be in the reverse bias. And if you take the zener voltage regulator, it consists of the current limiting resistance Rs. So that you can able to see the Rs, it is to be connected in series with the input voltage. So that input is applied here, and what is Rs is to be connected in series. What this zener diode connected in parallel with the load is in the reverse bias condition. So it is arranged in the reverse bias, and it is to be in parallel with the load resistance, so that you can able to see this is an optional, okay, load. And what this zener diode, it should be exactly parallel to the load here. And what this stabilized output voltage is always selected to be same as the breakdown voltage Vz of the diode. So its output voltage Vr is always equal to the Vz, because it is in the parallel. I think you have seen in the B triple E there, if the voltages is to be connected in so in the parallel, So it is going to be maintained the same there. Okay. So what the supply voltage Vs, it must be greater than the Vz. So in order to obtain the voltage Vz, what this Vs, it should be greater than the Vz input voltage. Okay, so that I'm going to explain again in brief here. The voltage regulator using the zener diode is to be connected as in this way. So the what this input is from the rectifier or from the it is filter, it is smoothing circuit. This is applied as input for this voltage regulator circuit, and the arrangement of this resistance Rs is to be in series with the it is input voltage, and this arrangement of this zener diode is to be connected in the reverse bias, and it should be in parallel with the load. So if you apply the unregulated input, it is an output of the rectifier or output of the it is the smoothing filter circuit is applied as input for this voltage regulator. And in this case what happens, it is going to flow, it is with the current as an is, and after that it is going to be divided as an il and the iz. Iz is the flow of the current across the xenodiote, and il is the flow of the current across the load here. And if so any of the input is above the Vz, so if you apply the Vs is, if it is to be greater than the Vz, so it is going to maintain the output voltage exactly equal to the Vz, and in this case whatever the extra voltage is there, it is going to be blocked or it will flow into the ground here. Okay, and if the Vs is less than the Vz, means its output voltage is equal to Vz only. I'm sorry, Vin, and it's what this zener diode is acting as an open circuit here. Understood? So in this important point to be remembered is the arrangement of the zener diode is to be in the in the reverse bias, and what this input voltage Vs, it should be greater than the Vz, and its output voltage is always equal to Vz only. If you increase the Vs after that, or if you decrease the Vs after that, and its output voltage is going to maintain constant as the Vz. This is about the voltage regulator using the zener diode. Understood? Okay, again I am going to repeat. So it is because it's very important circuit diagram. The input is an unregulated, it is to be taken from the rectifier or from the smoothing filter circuit, and the arrangement of the Rs is to be in series with the input, arrangement of the zener diode is to be in parallel with the load. And in this case whatever the input voltage which is applied, it should be greater than the Vz here. And in this case when the it is flow of the current takes place, okay, after applying the input voltage, so the voltage Vz, it is going to be maintained constant, and it is itself is equal to the voltage across the RL. So across the RL, the output voltage is always equal to the Vz only, and in this case whatever the extra voltage is there, it will flow into the ground. Understood? This is about the voltage regulator using the zener diode. And after that, if you take the line and the load regulation, it's the definitions. So what the performance of the voltage regulator, it can be determined using the line and the load regulations. Okay, what is the meaning of the line regulation? I think you have heard about what the main applied input is called as the line, and what this load is, it is an output operating device. Okay, so if what this line regulation is defined as the variation of the DC output voltage is when the DC supply changes by a given amount of the delta Vi. It is to be given by as the line regulation is equal to delta VL divided by VL into 100%. It is for the 10% change in the input Vi. So if the output voltage is going to vary according to the variation of the input voltage, okay, input for the regulator, so how much amount of the voltage it is going to change if the input voltage is going to change by the 10%. Suppose consider that if the input is equal to 1 volts, so if I apply as of the 1.1 volts, means what will be the output? And if I apply as of the If I apply as of the 0.9 volt as an input, it is what will be the output here. So how much amount of the output voltage it is going to vary according to the variation of the input voltage itself is called as of the line regulation. What this delta VL is called as the variation of the DC output voltage. What this VL is called as the actual output voltage. So the variation of the output voltage divided by the actual output voltage into 100% is going to give you the line regulation in terms of the percentage. If you take the load regulation, same thing. What this it is load regulation is the variation of the power supply output voltage. It is when the load current changes by the given amount of the delta IL. It is equal to delta VI. It is with respect to input voltage, but it is with respect to output current. It is with respect to the output current here. It is equal to, it is load regulation is equal to, it is a delta VL divided by VL into 100%. It is for the change in the delta IL here. Okay, so in this way you can able to measure the line regulation and the load regulation. So again I am going to tell you the point to be remembered. If you take the line regulation, it is mainly due to the variation of the input voltage. If you take the load regulation, it is mainly the variation of output voltage with respect to output current. ಇದು ಏನಾಗುತ್ತೆ, ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ವೇರಿಯೇಷನ್ ಆಗೋದ್ರಿಂದ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ. ಇದು ಏನಾಗುತ್ತೆ, ಔಟ್ಪುಟ್ ಕರೆಂಟ್ ವೇರಿಯೇಷನ್ ಆಗೋದ್ರಿಂದ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದ ಲೈನ್ ರೆಗ್ಯುಲೇಷನ್ಸ್ ಅಂಡ್ ದ ಲೋಡ್ ರೆಗ್ಯುಲೇಷನ್. ಓಕೆ, if you take the one more circuit, it is an op-amp series voltage regulator using the zener diode. It is also one of the example of an voltage regulator circuit. It is implemented with the transistor here. It is acting as the pass transistor, which is used as the control element here. So here, what this transistor acts as the control element, and what this R1 and the R2 is acting as the sampling circuit. So it is part of the output is to be taken and it is verified. So this is called as the sample circuit. The R1 and the R2 is called as the sample. And operational amplifier act as an error amplifier or the comparator. So that you can able to see it is an operational amplifier. It is acting as the comparator. It is one input will be the inverted in terms of the negative, and the other input will be the positive in terms of the positive here. What this zener diode along with the resistor R3 act as the reference voltage provider and the current limiting circuit. What this R3 is the current limiting, and what this VZ, it is used to provide the reference voltage. In this case, whatever the input voltage I am going to apply, it should not cross the reference voltage VZ. Okay, suppose consider that what this VZ is equal to 6 volts. So if I apply the input as of the 10 volts, I should get the output as of the 6 volts only, in that way. So this is acting as the reference voltage. Okay, again I am going to explain the construction of the op-amp series voltage regulator using the zener diode. It is consisting of the pass transistor. It is acting as the control element, and the R1 and the R2 is acting as the sampling circuit, and what this operational amplifier is acting as the error amplifier or the comparator. It is consisting of the two inputs. In this, one is to be taken from the sampling circuit, which is to be applied to the inverting terminal, and the another one is the reference voltage. It is to be applied for the non-inverting terminal, and this R3 is acting as the current. It is limiting the resistor. It is circuit, and what this VZ, it is used to give you the reference voltage. Okay, in this case, if you take the working of this one, see here, if the input voltage has been applied, it can vary. So according to that, it is going to give you the output here. Assume unexpectedly if the output decreases. If the output decreases means what here? I should take it to the reference. Okay, suppose consider that your output is equal to 6 volts. Unexpectedly, if it has been decreased to 5 volts, 5 volts means it is 1 volt has been decreased. According to that, it is what that decreased voltage is going to be available at the sampling circuit. In between the R1 and the R2 is also going to decrease. If it is going to decrease, what this decreased voltage is going to be applied as the inverting input for the error amplifier, and it is what is error amplifier is going to compare that voltage with the reference voltage, what this reference voltage is to be given by the vz. And if this is going to be decreased, the voltage will be more at the positive. If the voltage will be more at the positive means the base of the transistor voltage is going to be increased. If this voltage is going to be increased, I think you know that IE is equal to, it is IC plus IB. If this base voltage increases, according to that what this emitter voltage IE increases, and it is itself is the output voltage has been increased. ಮುಂಚೆ ಏನಾಗಿತ್ತು ಡಿಕ್ರೀಸ್ ಆಗಿತ್ತು, so it has been increased there. Okay, in this way output, if in this way what this decreased voltage has been increased according to the arrangement of the circuit here. Okay, again I am going to explain. If the output voltage increases, if the output voltage increases, the voltage at the sampling circuit also, I'm sorry, if the output voltage decreases, the sampling voltage decreases. According to that, it is going to decrease the input at the inverting terminal, and the voltage at the base increases, decreases, and what is base output of the comparator increases. So the base increases and the output is increased. In the same way for the opposite one, similarly, if the V0 increases, if I want the output to be 6 volts, if it is increased to 7 volts means, if it increases means the voltage at the sampling increases, the voltage at the inverting terminal increases, and the output of the comparator is going to decrease, because what this negative voltage has been increased. Or if the negative voltage increases means output will be decreased, output of the comparator is going to decrease, and what is base of what is base voltage is going to decrease, and according to that it is going to decrease the output voltage. In this way, if the output voltage, if it is going to cross the reference voltage, it can be taken back to the reference level. In the same way, if the output voltage decreases, again it can be taken back by increasing. Okay, again the output voltage is to be taken back to the required, okay, reference level. Understood? Understood the working of this circuit? If increases output, this also increases at the what is V minus increases, output of comparator decreases, and what this output will be decreased. In that way it can be explained. Okay, so this is all about the voltage regulators. So in this class we have studied what the definition of the voltage regulator. The output voltage is to be maintained constant. What is the need for the voltage regulators? So it should overcome the poor regulation. It should overcome the variations of the AC means it should overcome the variations in the temperature. This is the need for the voltage regulator. And if you take the circuit diagram of the voltage regulator using the zener diode, it is to be connected as in this way, in which the input voltage is to be above the what Vz, and the output voltage is always equal to Vz. It is constant. This is the voltage regulator using the zener diode. And if you take the definition of the line regulations and the load regulations, in the line regulations, the output voltage varies according to the variation of the input voltage. In the load regulation, so that output voltage is going to vary according to the variation of the output current. These are the formulas for the line regulations and the load regulations. Okay, and if you take the op-amp series voltage regulator using the zener diode, it is to be implemented as in this way, using the pass transistor, using the sampling circuit, using the comparator, using the current limiting circuit and the reference voltage provider, in which output voltage, if it decreases, it can be taken back to the reference. If the output voltage increases, again it can be taken back to the reference. Okay, this is all about the voltage regulators. And if you take the sample descriptive questions on this one means, so that he may ask you to define the voltage regulator and explain the need for the voltage regulator in the power supply, or he may ask you to describe the line and the load regulation, or he may ask you to write a circuit diagram and explain the zener diode using the voltage regulator. And also he may ask you to explain the op-amp series voltage regulator using the zener diode. All these are the possible questions which is concerned to it is today's class. Okay. So in the next class, we are going to explain about the IC voltage regulators. Okay. Okay. Thank you. Okay. Thank you very much.